All right, well, thank you for joining us again. Now, this is what I would kind of consider the challenge problems. So hopefully you know this packet and know where to find these questions. It should be linked below on our website too. So these challenge problems, these are conversions, but what makes these tricky is you have two measurements to keep track of and convert, and we'll do them simultaneously. So instead of just keeping track of one conversion, you got two conversions going on at the same time, one in the numerator, one in the denominator. All right, so looking at 23, it's asking you about the cost of coal. Now, the way I think of this, it's 4 cents, so 4 one hundredths of a dollar, 4 cents per kilogram. So that's actually pretty close to the going rate for coal, but 4 cents per kilogram. So the first thing we want to do is we're trying to get kilograms into tons. So I want kilograms to cancel, so I take kg. Instead of moving them down, you move them up. This number is 4 cents per kilogram. So I move kilograms up, change them to pounds. So now that is dollars per pound if I stop there. I don't want dollars per pound, I want dollars or cost per ton. So I'll move pounds up, change them to tons. And yeah, it's like 2,000 pounds is a ton. So that gets pounds to cancel. And if you look at the units that you're left with, the dollars, the money, stays up top, and the tons is down below. So that is the cost per ton. Okay. 24, I believe we did that one in class, and that's a monster. I mean, looking at those conversion factors I gave you, that was a lot to keep track of all those units on 24. Okay, 25. I kind of like this one. We've played around in class with a lot of these things. We just drop objects into our cylinder. So 25, it's really careful reading. And you just kind of have to make sense that, okay, I put water up to the 15 mark. I dropped this thing in there. Boop. The water it went up 3.3 milliliters. So when we're talking about the volume of the object, just don't forget it's that volume by displacement that determined how big it was. So we got our mass that was given to you, and you have the volume, which you figured out by displacement of water. So yeah, you just divide that mass divided by volume, and there we do have our density in grams per milliliter. All right. So remember, that's a simple way to identify a lot of metals. Just drop them in water and weigh them, and then you can look up the density on the chart. All right, back to conversions. Once again, it's two units at the same time. So we got to take meters to miles and minutes to hours. So we're converting two units at the same time. So yeah, if you've ever been to a swim meet, swimming 200 or 200, yeah, in 2 minutes is pretty good. You're a pretty fast swimmer if you can do that. So here I got meters, drop it down, change it to feet. So I just started with meters per 2 minutes. Drop the meters down, change it to feet. I'm going to take the feet, drop the feet down, change it to miles. And 1 mile is 5,280 feet. So remember how to read these parentheses. It's about what's in the numerator, what's in the denominator. All right, now if I stop there, that's miles per minute. I was curious how fast they're moving in miles per hour. So I'll take a minutes and change it to hours. 60 minutes is the same as 1 hour. And when you look at that, and you follow that calculator work, you're left with miles per hour. So remember, per is just like the division bar. That's how I think of it. So yeah, miles over hours. Miles per hour is what we're left with. That doesn't sound very fast, but when you're swimming, if you're swimming 3-4 miles an hour for a few minutes, that is exhausting. Yeah, you get really tired doing that. Okay, I like 27. It's really kind of asking you, all right, we're going to take this, imagine like a gallon of water, all right, or really a gallon of milk, and think about how heavy that is. That's really what this next question is asking you about. So we know the density of water. It's 1 gram per 1 milliliter. All right, so what we want to do is take grams, drop it down, and change it to pounds. A pound is 454 grams. So if I stop there and just did that, that would be pounds per milliliter. Okay, so don't forget to you're starting with 1, so you gotta include the 1 when you're starting with it. All right, now I'm going to take milliliters, change it to liters. 1,000 milliliters is a liter. And yeah, there was a mistake on this one. So depending on how you solved it, that's fine. But liters, we're going to move them up to get it to cancel, change it to gallons. And actually, what is it? It's 3.7 liters is a gallon. So yeah, I messed that up. I'm sorry when I was typing up the homework. So yeah, depending how you solved it, if you solved it with that other conversion factor, that's fine. But technically, yeah, it's 3.7, 3.8 almost liters per gallon. All right, so that, I think that's it, because that is pounds per gallon. So if you look at what you're left with is pounds per gallon. And I don't know if you've ever like picked up a gallon of milk. It's, you know, not quite 10 pounds, a little less, I guess. But yeah, so at least a gallon of water would be just less. A gallon of milk might be close. I don't know. Not quite. Yeah, so that does make sense. Right. So those converting 2 units at the same time, it's a little tricky, but it is the same process as before. Just get units to cancel and make sure your fractions equal 1. Thanks for watching the challenge set of conversion problems.